In math, you might have came across words like integers, decimals, real numbers, rational numbers, irrational numbers, etc., etc. But in this lesson, we are only going to focus on integers and decimals. So, what are integers? An integer is any number that cannot be written in the form of a fraction. For example, as you can see, -3, -2, -1, 0, 1, 2, 3, 4, 5, 1,000, 1,000,000,000,000. These are whole numbers and they can never be written in the form of decimals, as you can see here. So decimal numbers, they are opposite to integers, which means they can be written as decimals. As you can see here, 1.2, 2.444, -0.999, and 2. And there's one thing that I want you to note, that decimal numbers can be integers, but integers cannot be decimal numbers. What I basically mean is that 2 can be found in the decimal class, but you can never find 2,44 in the integer class. In programming, what you just saw is called data types. Basically, data types are just reversed words that are used to declare different names and their specific kind. Before I get to explaining what data types are, there's one thing that I want you to note here. How each and every data type is written in lowercase or small letters. This is the correct way of declaring a data type in C++. Each and every data type must be declared in small letters. For example, if I declare a string and each and every letter is in small letters, you can see it's green. That means it's correct. So if you try to put a capital letter S, it changes the color. So right now, this is not a data type. So make sure when you declare data types, they must be in small letters. That goes the same for int and for float, for each and every other data type there is in C++. Just keep it in lowercase. And here, the first data type, we have the string data type. This is the data type that is used to declare a string of characters. For example, I am going to declare an example of a string data type, which is, I'm just going to call it full name. And in this, I'm going to store a full name. For example, Brian Jones. Well, I want you to notice how I have stored this name in double quotation marks. This is a rule you need to consider every time you are declaring a string data type. Each and every string is stored in double quotation marks. Just keep that in mind. So I'm just gonna run this, and as you can see, it displays Brian Jones. Well, and there's another thing that you can do with string data types. You can even store single letters. As long as they're in double quotation marks, you can even put anything there. You can put numbers, letters, or single letters, or keywords, or you can just put, as long as they are in double quotation marks, C++ will know that this is a string data type. As you can see, you can even put numbers, but the thing about numbers is if you store them as in a string data type, they cannot be changed, or you cannot use them to multiply numbers later on. They stay as numbers. So they can't be changed. C++ reads them as words, for example. So that's how strings are. That's how they work. And remember, always put double quotation marks when you're declaring a string data type. As you can see to your left, there's an example where we stored William Brown inside the string name. Just uses the same principle. Right now, let's look at int data type. They are used to store int numbers. So as you saw from the last video, 1, 2, 3, any number that cannot be a fraction. That goes the same for long data type. It's also used to store integer numbers, and short is also used to store integer numbers. So basically, they do the same jobs, all these three different data types. If you don't want, you can use long. If you don't want, you can use short. If you don't want, you can use int. So the mostly used one is int. Everywhere you go, int is used most. So I prefer that you use int too. As you can see here, I'm just gonna initialize a variable of number and declare it as int. And I'm going to store 2 in number 1 and number 2, and I'm going to add them together and see what they display. I'm going to run this, and as you can see, it gives us the answer. So If I don't want to say int, I can also say long. Let me just change this to long, and let's run this and see what it gives us. It still gives us the same answer, so it has the same effect. If you don't want to say long, you can also use short. Change this to short, and I'm going to run this. It still gives 5. So same effect, different data types, and same, they do the same thing. They do the same job. Int, short, long, same, but just use int for simplicity. Right now, let's look at two important data types, which is float and double. They are both used to declare decimal numbers, which means numbers with floating point, aka numbers with a point in them. So for example here, let's say I want to declare the price of 2 items. I'm just gonna call this float price 1, and I'm going to declare a second float and call it price 2. Right now, let's give price 1 a value. Let's say 1,5. Let's also give price 2 a value. Let's say 1,5 again. So for simplicity, right now let's add both prices of both items and see what it will give us. Well, if you are a math genius, you probably done this in your sleep, which the answer is 3. So this means that float it's safe to store decimal numbers in float. Okay, let's change this to double and see what will happen. So I'm just gonna change float to double for price 2, from float to double for price 1. And let's run this and see what the output will be. As you can see, it gives us the same answer. So it means that float and double, they have the same effect on decimal numbers. So if you don't want to use float, you can use double. Here's another important data type, which is char, fully pronounced character. It is used to store a single character. As you can see here in the variable gender, I've stored a character of F which represents female, and I am a female. Well, except for my voice. I'm joking, I'm a male. So here's an example here. If you declare each and every single character, first you just say char, and then you give it a name, and then you're going to give that name a value. In this case, let's say M. So I want you to notice how I've stored M in single quotation marks. That's because you want to store it as a character. And the way to, memorize this is to think of a character that it basically stores single characters. So you use single quotation marks to store a single character. So just keep that in the back of your head. Here's an example of a bad way of declaring a character variable. As you can see, I have an error. M was not declared in this scope. That's because C++ has no idea what M is, because I didn't put the single quotation marks around M. So every time you declare a character variable, make sure you use single quotation marks. And the interesting thing about characters is you can store anything in them. You can store even a symbol, a number, a letter, a word, anything. So here I'm just going to give you an example where I'm going to be storing a symbol, and let's try to display this symbol and see if it's going to display the same thing I want it to display. So let's run this. As you can see, it displays exactly the same symbol that I've stored inside the variable. So you can even store letters or anything. So let's try to store 2 characters in a single variable. As you can see, it only gives back 1 character, which is the last character. This is how the character variable works. It doesn't care how many characters you store in a single variable. Whatever number of characters is going to take the last of those characters. For example, here if I put R at the end of CS, guess what the output will be? R, because R is at the end of that string of characters. So it's going to take a single character. So that's why we say single character. That's why we say that. Here's an interesting data type, which is bool, a shortcut for boolean. A boolean is a condition data type, which means it depends on whether a condition is true or false. Let's look at an example to illustrate this. Let's declare a bool variable with a condition as raining, and we're going to initialize raining as true, which means it's raining outside. So right now, let's create an if statement that will display the appropriate message. Don't worry about if statements. I'm going to get deep into them in the upcoming lessons. So here at the first line, let's say if it's raining, take an umbrella. So take an umbrella and line, and else if it's not raining, display leave the umbrella at home. So now remember, we initialized the condition of raining to true. Let's run this and see what will happen. Well, it's going to display take an umbrella since it's true. As you can see, Chris is very upset. He doesn't like it when it rains. What if we set this to false? Let's say it's not raining, maybe it's cloudy or sunny outside. Guess what the output will be? Yep, we're gonna have to leave the umbrella at home. So that's what Boolean statements are. They are condition statements that depend on whether a statement is true or false. So thank you for joining me, guys. See you in the next lesson.